Welcome to Pure Mathematics 1, Chapter 1 Algebra, topic Simultaneous Equations. For mathematics, sometimes you have to solve for more than one variable. You have to solve for 2 or 3 variables. And for the equation, you have to involve, if you want to solve for 2 variables, you need to have 2 equations and you have to solve them at the same time. So they are called simultaneous equations because they are solved at the same time by using both equations to find the 2 variables. If you need to find 3 variables, so for 3 variables, you will need 3 equations and they are simultaneous too because they are solved at the same time, because the word simultaneous means at the same time. First of all, I would like to talk about the linear simultaneous equation. So for the linear simultaneous equation, they only involve variables such as x or y or z or m and n. They don't involve x squared, x cubed, or something that they only involve the variable to the power 1. Now I would like to introduce you guys 3 methods to solve a linear simultaneous equation. First of all, I have to provide a linear simultaneous equation. I have an equation like this: 4x plus y equal to 17, and 2x minus 3y equal to minus 9. The first method is elimination. Look at these 2 equations. I can see minus 3y in here. See minus 3y in here. So I want to eliminate it. I would have 2 plus 3y in here. So I can eliminate this one. But I can see y here. So how I can use y here to eliminate the minus 3y here? And this equation is 2. 1. In order to get 3y, I would multiply the first equation multiplied by 3. So I have 12x plus 3y equal to 51. And I have my second equation, 2x minus 3y equal to minus 9. So I would add these 2 equations in order to eliminate the 3y. So when I add them, I have 14x plus 3y minus 3y equal to 42. So 14x equal to 42, and x will be 3. If we have the values of x, we know that 4x plus y equal to 17. So 3 times 4 plus y equal to 17, and result in y plus 12 equal to 17, and y equal to 5. So that's how we can use the method elimination to find the values of x and y. The second method I want to introduce is the method substitution. Here I have y plus 4x equal to 17. So y equal to 17 minus 4x. So I will substitute this one, the y. I change y into x. So I substitute in this equation. So in this equation, they only involve the x only. So I can solve it easily. And when I substitute, I call this equation is 3 into 2. I will have something like this: 2x minus 3 multiplied by 17 minus 4x equal to minus 9. So I have here 2x minus 51 plus 12x equal to minus 9, or 14x minus 51 equal to minus 9, and then 14x equal to 42, and x equals to 3. So we would do like the first one to get the value of y, which is y equal to 5. The third method to solve a simultaneous linear equation is using the intersection of the graph. So now we have to draw a graph of the equation. We have two equations, 4x plus y equal to 17 and 2x minus 3y equal to minus 9. Now we will draw and represent them in here. X here and y here. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. And for the first one, as you can see, when x equal to 4, y equal to 1. So it would be this point. When x equal to 5, y equal to minus 3. Which is this down here. So I connect the 2 points into the line of the equation 4x plus y equal to 17. It's a line of that equation. The second equation, 2x minus 3y equal to minus 9. When x equal to 0, y equal to 3. I will take another color to illustrate that. When x equal to 0, y equal to 3. When x equal to 1, y equal to 11 over 3. 11 over 3 when x equal to 1. 11 over 3, which is this one. You connect the 2 points here, and you will get this graph. If you do it correctly, my graph is a hair because I cannot do it really accurate. So if you do it correctly, you would get something like this. The intersection is the value you want to look for. X equal to 3 and y equal to 5. That's how we solve by using the intersection of the graph of the equation. Now we will look at the nonlinear simultaneous equations. From the previous question and knowledge before, we see that the both equation of the simultaneous equation are both linear, but for P1 content and P1 curriculum, the only non-linear simultaneous equation you have to face up with is that one of the two is linear simultaneous equation and the other one is not linear. Let me take an example and we will work through that example. I have a pair of non-linear simultaneous equation. I have x squared plus y squared equal to 10 and x plus y equal to 4. This one is linear. This one is still linear, but this one is not linear because it contains x to the power 2. And how we can solve this one? For this type question, we will use the linear equation to find one of the to change the whole thing into only x or only y. It depends on it. We have x plus y equal to 4. So now I want to change y equal to 4 minus x. Now we'll substitute So for this type, we use the linear equation to substitute y equal to something x, and we substitute that y into the other equation. Substitute y equal to 4 minus x into the first equation into 1. After substituting y equal to 4 minus x into the equation 1, this is what we can get. X squared plus 4x. This one is square because it equal to y equal to 10. And then x squared plus 16 minus 8x plus x squared equal to 10. So we have 2x squared minus 8x plus 16 equal to 10. Then 2x squared minus 8x. We move this one to the side, plus 6. 16 minus 10 is plus 6, which is 0. We see the common factor here, so we would make it out here. X squared minus 4x plus 3 equals 0. So this one equals to 0. We don't care about this part anymore. How we can solve the equation? Back up here. X squared minus 4x plus 3 equal to x squared minus x minus 3x plus 3 equal to x multiply x minus 1 minus 3. Here's x minus 1. We got minus 1 multiplied by minus 3 is plus 3. So we take our common factor, multiply by x minus 3. So x can be either 1 or 3. With x equal to 1, we got x plus y is equal to 4, so y equal to 3. And with x equal to 3, y equal to 1. So this is two possible outcomes we can get. Either x equal to 1 and y equal to 3, or x equal to 3, y equal to 1. This is how we can solve nonlinear simultaneous equation by using substitution.